In a world where space and time are intertwined, one man dared to challenge the status quo. His name? Dayton Miller. His weapon of choice? A flute. But not just any flute. This instrument held the power to unleash the ether, a pervasive medium once thought to fill the universe. Miller, a physicist by trade, a musician at heart, discovered a harmonic resonance within the ether. He found that his flute, when played with precision, could manipulate this elusive medium. His melodies, a symphony of science, had the potential to shift the very fabric of reality. However, a sinister force lurked in the shadows. The Einsteinian demons. These creatures thrived in the distortion of space-time, causing chaos and disruption. The world needed a hero, and Miller was ready to answer the call. With his flute in hand, Miller played a tune that echoed through the cosmos. Each note, a shot of pure ether, struck the Einsteinian demons, dispelling them back into the void. The world was saved, not by a warrior, but by a musician, a scientist, a man with a flute. Remember, in this universe of wonder and mystery, sometimes the most unlikely heroes make the biggest impact. Keep your mind open, your heart brave, and who knows?
All right, hello and welcome, lads and ladettes. Today we're going to be doing a presentation on the history of time dilation and the twin paradox. So thanks everyone for joining. If you want the citations or the presentation, you can find them on my Obsidian website where I publish all my presentations. You can find the sources here at search.spaceaudits.net. It'll take you to the EtherCause GitHub. And from there, you can search all the citations in here. Shout out to Toby for making that accessible for everyone. And as always, if you want the full PDF library and the organizational structure that comes with it, you can hit up my Telegram here with these links that you can find on the Obsidian page. And you can download the whole thing directly and import it to your thing. So I was going to put a slide here, but I forgot about it until a couple minutes ago and didn't have time. But this is the less important slide. But anyway, if you do a quick search on Google and type, twins, aging, paradox, astronauts, that's usually what they'll equate it to. And they'll say that these twins were born, at the same time on Earth, and one of them went to space. And due to his orbit and speed and all that around the Earth, he experienced time dilation. And now he's a little bit younger than his twin by a couple microseconds. You can find a bunch of stories like that. So we're going to get into what that means exactly, because in actuality, relativity says that for the two frames to be indistinguishable, the stationary twin also has to reciprocate in that time dilation, so they would both be young with respect to one another when they return. But nobody talks about that aspect of it because it's paradoxical and illogical. So we'll get into, so this presentation is primarily covering the history of time dilation and the twin paradox as told to us by A.G. Kelly in chronological order. And from that, we're going to get into the history of Herbert Dingle, who expanded on the twin paradox and really tried to get some answers to it and found that there are none. So not sure why this slide is messed up. But anyway, okay, so we'll get into what Kelly lays down here. So he says, let us set down the details. If a twin goes off into space for a long trip at nearly the speed of light, that twin would be much younger on the return than the twin who stayed behind. And you could find multiple instances of people referencing this: Fock, French, Hawking, and Young. If the twins were 5 years of age when they were separated, and the speed of separation v was 0.99999 c, then when they would return after 60 years, as time measured on Earth, the one twin who remained behind would be 65 years old, while the traveler would be 5 years and 1 month. And then he goes over the relativistic math to show that with the gamma factor correction for time dilation. And all the math checks out. So what's the issue here? Well, the issue, as I pointed out earlier, is that relativity says that the twin on Earth would also have to experience that. Otherwise, you could differentiate between the stationary frame and the moving frame. So that's a huge problem that we're going to expand upon. But before we get to the expansion upon that, we're going to go over the basics of relativity theory so we can understand what's being put forward and why this is paradoxical. So Einstein says here that the equations of like Newton's mechanics hold good in inertial frames, and if they're good in inertial frames, then they'll be good with his theory too, where he's defining an inertial frame as a frame that's in uniform translatory motion, so just linear motion at a constant velocity. So he says here, we will raise this conjecture about the laws of mechanics holding good in the frame to the principle, or to a postulate called the principle of relativity, and we'll introduce another postulate on top of that is irreconcilable from the former, namely that light is always propagated in empty space with a definite velocity c, which is independent of the state of motion of the emitting body or the receiver, the observer. The introduction of a luminiferous ether will prove superfluous inasmuch as the view here to be developed will not require an absolutely stationary space and provide special properties to it, nor will we assign velocity vectors to a point in empty space where electromagnetic processes once took place. So he's not going to invoke any absolute time or any absolute space. Everything is relative based on the constancy of c, and this leads to the consequence of relativity of simultaneity, where two observers, one in motion, one not, will make two different observations of a simultaneous event that cannot be defined as simultaneous in the moving frame. So in other words, it implies that there will be different physical outcomes based on the velocity, which we'll cover as we continue. So Einstein goes on in his 1905 paper to define how this works for distance and how the stationary observer, when looking at the rod of the moving observer, would notice that their rod is shorter, and that would be reciprocal in the stationary frame. But he doesn't mention time so much in that one. But then he goes on to say, but keep in mind, space-time symmetry is, it's called Lorentz symmetry. And what that entails is that when you're changing the x-axis, the distance, the length, when you're link contracting, you also have to change the time, because as Einstein said, we're not going to assign properties where the processes once took place, and time is going to be different in all frames, which, relative to as a function of velocity, essentially, which we'll continue on here. So he goes on to say, and if a clock at A is moved with a velocity nu along a line AB to B, then on its arrival at B, the two clocks are no longer synchronized, but the clock moved from A to B lags behind the other, which has remained at B by 1/2 times TV squared over C squared, T being the time occupied by the journey from A to B. It is at once apparent that this result still holds if a clock moved from A to B in any polygonal line, and also when the points A and B coincide. If we assume that the results proved for any polygonal line is valid for it must also be valid for a continuously curved line, and we arrive at this important result. If the two synchronous clocks at A are moved close to the curve, or moved in a closed curve at a constant velocity until it returns at A, the journey lasting t seconds, by then the clock will remain at rest, will have traveled the clock on its arrival at A will be slower than that factor given earlier. Hence, we conclude that the balanced clock at the equator will move slowly by a very small amount and precisely similar to a clock located at the poles with identical conditions. So the equations not only apply in uniform translational motion, so a straight or rectilinear, so a straight line, but they also apply in a circuit that's in uniform motion as well. So you could go around in orbit and it would still apply. So that's what he's saying here. All right. So then he goes on to give his definition of simultaneous events in relativity of simultaneity. So here we say, if we wish to describe motion of a material point, we will give the values of its coordinate as a function of time. Now we must bear carefully in mind that the mathematical description of this kind has no physical meaning unless we are quite clear on what we understand by time. We have to take into account that the judgments in which time places a part are always judgments of simultaneous events. And he goes on to say that if at 7 o'clock his time, a train arrives, every day, then when his clock hand hits 7 o'clock and that train shows up, that's a simultaneous event. But an observer moving at some velocity, and he's got his own clock and he's looking at it. Well, his clock is going to be different than what Einstein says. So he's not going to perceive the event as the train and Einstein's clock watch hitting the 7 o'clock dial at the same time. It's going to be different for him. So then he goes on to say, and in fact, such definition is satisfactory when we are concerned with defining time exclusively for a place where the watch is located, but is no longer satisfactory when we connect the time in a series of events occurring at different places, or what comes the same thing to evaluate the times of events occurring at remote places from the watch. So he's defining in the coordinate system the t and t prime are not physically connected. They're functions of velocity. There's a difference in them by a function of velocity, which would dictate different simultaneous events. And this is true because when he goes on to say here, when questioned about link contraction and time dilation being actual mechanisms, some people will say that, oh, it's just an apparent effect and it's not real, or that I don't even know what they say, but they say like different things about basically trying to excuse the fact that link contraction and time dilation are real mechanisms. And here in 1911, Einstein goes on to make the correction here and lay it out. And he's like, it does not exist in reality as much as it does not exist for the moving observer, but it does exist in reality in such a way that the principle could be detected by means of a non-moving co-observer. So in other words, he's saying that as a function of your velocity, relative to whatever, you're going to experience contraction that'll be relative to whatever you're looking at, or whatever you're doing whatever velocity you're using for the observers when you make the other one stationary. So it's not an absolute contraction based off of the velocity, because otherwise the velocity would be absolute, and it would be measured against absolute space, and that's not what they're going for. These are different link comparisons based on the motion of the observers and the relative motion between them. So then in 1920, he goes on to clarify about the meaning of simultaneity. He says, are two events like two strokes of lightning, A and B, which are simultaneous with reference to the railway embankment, also simultaneous to a train? We shall show directly that the answer must be in the negative. When we say that lightning strikes, A and B, are simultaneous with respect to the embankment, we mean that the ray of light emitted at the places A and B where the lightning occurs meet each other at the midpoint of M of the length between A and B of the embankment. But this event, A and B, also corresponds to positions A and B on the train. Let M1 be the midpoint of the distance between A to B on the traveling train. Just when the flashes of lightning occur, this midpoint M1 naturally coincides with the midpoint M, but it moves towards the right of the diagram with the velocity v of the train. If the observer sitting at the position of M1 in the train did not possess this velocity, he would remain permanently at M, and the light rays emitted from the flashes from A to B would reach him simultaneously. They would meet just where he is situated. Now, in reality, consider the reference of the railway embankment. He is hastening towards the beam of light coming from B, whilst he is riding ahead of the beam of light coming from A. Hence, the observer will see the beam of light emitted from B earlier than the one emitted from A. Observers who take the railway embankment as their reference body must therefore come to the conclusion that the lightning flash B took place earlier than the lightning flash A. Thus, we arrive at this important result. Events which are simultaneous with reference to the embankment are not simultaneous with respect to the train, and vice versa. This is relativity of simultaneity. This is a consequence of the constancy of c. You don't measure it proportional to your velocity in the Einstein paradigm. It travels at a constant c. So when you're moving towards it, it's going to get there faster because it's traveling less length to you than the one that's further away. Every reference body or coordinate system has its own particular time unless we are told the reference body to which the statement of time refers to. There is no meaning in the statement of time of an event. So let's see. I'm going to add on to that. The vice versa. So in other words, the simultaneous event is not simultaneous in both frames. And if the laws of mechanics hold good in both of these frames, then that's going to dictate different physical outcomes based on them. It is not going to dictate that the event itself is simultaneous. Relativity of simultaneity comes at the expense of actual simultaneity. So to say that the outcome would be the same in both frames is a misapplication of relativity theory. One frame has the simultaneous event and the other does not, which has to lead to different physical outcomes. So I've given the example before here. We've seen with the balance beam and a moving observer, is the velocity of the observer going to change when A and B hit A1 and B1 on the balance beam? No. And you could have this guy go in a circuit, or you could have him go in a straight line and never return, doesn't matter. But the events will never be different. They'll always have the same outcome that agrees with the stationary observer. So this is showing that there is a preferred frame and that that absolute, or that time and space are absolute, and simultaneity is absolute. It's not relative. Because if it was relative, then what would happen here is your boy would have, in his timeline, he would see these fall down and bounce back up at the same, there would be no deviation because they hit the balance beam at the same time. But the moving observer, due to his velocity and time difference and the laws of mechanics holding good, would dictate that when B hits first, it's going to offset this balance beam. And when A hits, it's going to cause a deviation. It's going to cause that ball to get deflected off. But that obviously doesn't happen. So huge problem. Now, to make things even more clear to what Einstein is saying about the reciprocity of time dilation for the stationary clock, because like I said, if you could tell that the other clock doesn't have any time dilation experience, then you could use that frame as a reference for all other motion. But relativity says that all motion is relative, and you can't distinguish between the frames. So in order for that to be true, to be logically consistent, you would have to argue reciprocal time dilation for the stationary clock. And he gives his example here for the moving clock. And he says, these two consequences, which hold mutatis mutandis for every system of reference, form the physical content free from convention of the Lorentz transformation. So mutatis mutandis is a fancy way of saying vice versa. So it has to be reciprocal. And this was in 1922 where he's saying this. So we're going to get into some experiments at the end here that say that they've proven time dilation. Well, they've certainly shown a one-way variation in clocks due to velocity, but not the reciprocal end of it, which is required for relativity to be true. So we'll definitely touch back on that at the end. And then here in 1916, when he's talking about his general theory of relativity, he goes on to add that the word special is meant to intimate that the principle is restricted to the case of K prime as a motion of uniform translation respectively to K, but that is equivalent of K prime and does not extend to the case of non-uniform motion of K prime relative to K. So what he's going to propose here is that acceleration and deceleration will have different time dilation effects, and that'll be invoked later in some explanations that people give to try and explain this twin paradox and how it could work out such that the stationary clock doesn't have to reciprocate in time dilation with respect to the moving clock. But we'll show that that's an inaccurate analysis and use of relativity theory. So Kelly throws his own twin paradox in the mix, and he says, "Let us devise such an experiment. Let 5-year-old twins pass each other by in outer space while moving in a straight line at a uniform speed." Because he's trying to keep it to just special relativity, because people will say, oh, well, when the twins return, they have to stop and slow down. There's an acceleration deceleration phase. During that phase, the time dilation is going to be different, so it's going to have different results, blah blah blah, right? They try to make special relativity not apply to it. But anyway, so his example is specifically keeping it into the confines of the special theory. So they do not ever arrange to meet again. So they're not on a continuously curved path, and they're not going to stop and come back to each other and go through an acceleration deceleration period. We assume that the twins travel at a mutual speed recession of 0.99999 c with respect to each other. If they continue on that speed for 60 years as understood by either of them, then according to the special theory of relativity, without ever decelerating or reversing, the age of each person according to the other would be reckoned as 5 years and 1 month, as the example earlier that he gave and showed, the math for it, for how it would work. It is not necessary for the two to reach each other ever again or return to the starting place to verify this. You can use the calculation according to special relativity to show this to be true. But now we have a problem. The aging has not occurred during any acceleration or deceleration phase. The different aging has occurred during uniform movement in a straight line with respect to one another. If the twins had separated from each other in outer space rather than on Earth, they would have no way of knowing which is the younger and which one was stationary. According to either twin is younger. And if they were able to send photographs to each other at that 60-year mark, they would both expecting one another to be, at that 5 year, 1 month age. But what they would get is a picture of them old. And because you have to use the other one as the stationary frame and vice versa. So that makes it so that they would both have to be old and also young with respect to one another. But what physically happens, right, is that they're old and they can't be young with respect to one another. Because otherwise you would have a preferred frame. You would be able to tell which one is moving. So this leads to, that paradox. We have the retardation of a moving clock paradox. So this is a comment by Muller in 1950, I think. He goes on to say, fully acknowledging the paradox as well, i.e. a clock which is moving with a velocity nu relative to s will be slow compared to the clock s. When we keep in mind that the system s and s prime are equivalent, it is obvious that the clock at rest s similarly will lag behind the clock in s prime. So here, a second, little choppy on the audio. How's the audio sounding?
Might just be me.
Oh, it's okay.
Oh, you're good here.
Gotcha.
You're good.
Gotcha. Okay. Yep. Okay. So what we've established here is this is canonized, right? This reciprocal time dilation situation. We even have Einstein commenting on it with his vice versa, mutatis mutandis or whatever. So now we're going to get on to the escapades of Herbert Dingle, who was searching for a solution to the twin paradox. So who is this gentleman, you may ask? Well, he was a professor for many years and taught relativity theory to undergrad students. He wrote textbooks on relativity theory in 1920 and 1940. He wrote for the Encyclopedia Britannica for decades. And when he started to question relativity and then, came up, he was morally conflicted. He was I'm not going to keep writing for the encyclopedia telling people how great this theory is. He was like, yo, I'm out, boys. And they respected his opinion so much that they were like, hey, why don't you document your contentions and we'll publish those? So he was like, okay, cool. So this is how much he was respected in the field as an expert in relativity theory. So he was praised by Max Born in Max Born's book in 1940. And this book from 1940 was used for several decades, and it received 4 editions and updates. He was well respected by the relativity lads, Einstein, Eddington, Tolman, and Born. They were always getting into, conversations about relativity theory, and Einstein was commenting on, how Dingle was the man. And Tolman even had Dingle do some formulae for him in his book, Thermodynamics and Cosmology in 1932. And in an enlarged edition of Einstein's 1954 book, it's prefaced with Dingle being at the top of the list of citations, and the citations are not listed in data or by order of date of publication. So basically, it's a nod from Einstein, like, Dingle's at the top of the list here. He's the man. He gets it. Everyone else, you guys also get it, but Dingle gets it the most bestesses. That's what I take out of that. Now, after he started questioning relativity, and through this twin paradox, which can easily be understood as something that leads to logical contradictions and can't possibly be true in nature, thereby eliminating it as a theory that accurately describes reality, he was labeled an outcast and a crackpot. And what was his crimes? Well, he started asking about the twin paradox and how it could be resolved. And when he didn't get a sufficient answer, he just asked the same question again, and everyone got super mad at him. So he gives a warning in his book. So what he had to do after he was denied publication for years, which we'll get into, but what he ended up doing was he had to publish his own book and kind of chronicle this whole story out. And he gives a warning here about how in math you can use sometimes an equation will give, that there's multiple solutions to a problem, and sometimes they're non-physical, they have no meaning, and you reject those ones and you take the one that has physical meaning. So he gives the example of trying to find the volume of a cube, and basically it gives two answers. It gives the number 2, and then it gives the square of -3 minus 1. And then the other solution is the negative square of -3 minus 1, which have no physical meaning, but they're mathematically valid. Like, you can calculate them and you'll get the output, but there's no ruler that measures the square -3 minus 1, or that measures in negative squares. But you know that 2 is a real unit. You can have something that's 2 inches, 2 feet, etc. Right? So you disregard these other 2 and you use the 2. And he goes on to say that in relativity, the use of a Lorentz transformation is said to be the valid transformation, and the use of a Galilean transformation is invalid. So in the same respect that you can get nonsensical answers, what's put forward in the mainstream is that the Galilean transformation would be one of these nonsense answers when you're dealing with relativistic effects, and you have to use a Lorentz transformation to get the proper answer, which would give you your physically meaningful result. So we'll read a little bit here from Dingle's paradox here, or what he's saying about the math. But the theory requires that you cannot distinguish which clock is the moving one. It is equally true to say that A rests while B moves and B rests while A moves. The question therefore arises, how does one determine consistently with the theory which clock works more slowly? 1 second. Unless the question is answerable, the theory avoidably requires that A works more slowly than B, and that B more slowly than A, which requires no superintelligence to see as impossible. Now, clearly, the theory that requires an impossibility cannot be true, and scientific integrity requires, therefore, either that the question posed shall be answered, or else that the theory shall be acknowledged to be false. But as I have said, more than 13 years of continuous effort have failed to produce either response. The question is left by experimenters to the mathematical specialist, who will either ignore it or shroud it in various obscurities, which they certainly do, while experiments involve an enormous physical risk on them being performed.
That's what Dingle said?
Yep. Yeah, dude, he says a lot. It's good stuff.
It's hilarious. It doesn't take super impossible intelligence to figure out that relativity's dog shit.
Yes. So, let's see here. So this is back to the justification for using a Lorentz transformation over a Galilean transformation, which I kind of already covered with the physical meaningness of it. But he goes on to say that the special theory of relativity regards that the second is true and the first is false. So Galileans out, relativity transformations are in, such that either clock can be arranged so that it works slowly than the other. And then he goes on to the nonsense results, which reciprocal time dilation in the moving frame is a nonsense result. He says, hence, without at least rejecting the Lorentz transformation as a mathematical solution of the problem, we can say at once that it is not possible for it to be a physical solution. Nevertheless, in modern physics, it is universally assumed to be so on the sole ground that it is mathematically valid. So I can compute it, therefore it is true, is what they're going with. And a quick refresher on Galilean relativity. It's measurements against absolute time and space, where you just do velocity addition. There's no restriction. So let's say you're on a train traveling 50 kilometers an hour and you're walking in that train. Well, you're now at a combined velocity of 55 miles per hour relative to some other observer, which would be absolute space. That would be your actual velocity. And then here's what the transformation for a Galilean transformation looks like. You got your x coordinate is going to be a function of velocity times time. And your time coordinate is going to be the same in all frames. The only thing that changes is your position with respect to time based on your velocity, not with time doesn't change as a function of your velocity. That's the biggest distinction there. In relativity theory, velocity addition combines nonlinear following relativistic velocity formula. So basically they're making it so that nothing can ever exceed the speed of light using a formula to make sure that that never happens. And nothing travels faster than c, and c is constant in all reference frames. And when you're moving at really fast speeds, you have to use the Lorentz transformation, they say, to deal with this, to make everything consistent. Otherwise, you're going to end up with results that would be c plus or minus v, and they can't have that. So this is important because the special relativity transformation motion gives distinct outcomes for simultaneous events, which will be important later, because some people will argue that the synchronizing of two clocks and then moving them is a simultaneity issue, which goes against what Einstein put forward. But here's a quick look at the Lorentz transformation. Your time is going to be gamma factored, and then it's also going to be a function of time minus velocity and distance over c squared. And then your x-axis, your link contraction time dilation, your space axis is also going to be contracted by the function of velocity and time. All right. So Dingle starts publishing his concerns, demanding answers for relativity theory. So as we read earlier, he went on a 13-year conquest trying to figure this out. So he says here, but the theory also requires that you cannot distinguish between the moving clock. It is equally true to say that while one rests, the other one moves, and vice versa. Now, clearly, that theory. Oh, that's the same exact slide, I think. My bad. So after he was posing these questions, yeah, my bad. That was the same slide. So after he starts publishing or trying to publish these in Nature, he gets a message from John Maddox, who was the editor at the time, and he says, you can't challenge the Royal Society, bro. I don't know who you think you is, but you can't come around here challenging the royal lads. And so he takes it up with the Press Council Committee and some committees within the Royal Society that handle these matters to try to get some adjudication. And the Royal Society and the Press Committee come to the conclusion that John Maddox did nothing wrong and there was no ethical violations and it was completely sound. Even though he gave no reason as to why he couldn't question the Royal Society, it was just simply, can't do it, bro. I would not be prepared to let you issue a challenge to the Royal Society in Nature. So just got straight blocked. And then nobody wants to be like, hey, let the man publish his thing. We'll go ahead and defend relativity theory, right? Like you would think one would do, but they didn't do that. So it came to the point where he had to write 300 letters to the current members of the Royal Society at that time. And we'll read a little bit from it here. Is to the fellows of the Royal Society. Dear fellow, I enclosed a copy of a letter which I submitted to Nature on August 9th. After 4 months, it was refused publication on the sole grounds that the editor would not allow the Royal Society to be challenged in Nature, the publication. Challenge is the editor's term for what will be seen to be a request for general enlightenment, which the Royal Society has privately declared itself unable to provide on a matter of great scientific and public importance. Repeated requests have failed to draw from him any justification for his decision. It is simply reiterated. Two distinct aspects of this situation demand attention, and in the first place, the fact that nothing will induce anyone to publicly answer a very simple disproof of special relativity, while in private or anonymously, I am offered a variety of mutually contradictory answers, all so palpably irrelevant that the reason for their author's unwillingness to acknowledge them publicly is crystal clear. These facts admit only one explanation. This disproof of special relativity is so plainly conclusive that no one guided by reason can doubt it, and also it is unexpected that no one guided by prejudice can believe it. Those called upon to comment, therefore, cannot produce a refutation, but fear that if they accept the disproof, someone will discover a flaw which has escaped them and their incapacity will be exposed. Hence, they keep silent. No other explanation is consistent with the abundant evidence which I possess, but no such evidence is needed to confirm that there can be no respectable origin of more than 8 years unyielding refusal to meet publicly a simple and repeated published criticism of one of the most fundamental principles of modern physics. To the hazards of attending the covert apostasy of its practitioners seem indifferent. So people were writing him on the back end while he was questioning this and making a fuss about it, but they weren't willing to stand on it publicly. They weren't willing to publish it as an answer because it's nonsense. You can't have the stationary clock it doesn't work that way. It's never been observed, and it makes no sense for them both to be running slow with respect to one another. But this is required, right, of the theory, and nobody was able to defend it. So he gets into the second part of his reasoning why this is dangerous. The second aspect of the situation is this. From now onwards, scientists will control the physical safety of the population to a degree never before attained by any man or body of men. Since their free and potentially catastrophic activities are too abstruse for a general understanding, without complete prohibition of scientific research, the public is thus compelled to trust implicitly in the integrity of scientists, and it has therefore an undeniable right to the assurance that integrity is being maintained. Its only medium for the assurance is scientific press. The general press, as I know since I have approached them daily and weekly in the journals, quite understandably consider itself unsuitable for this purpose, since the raising of such matters would almost certainly generate discussion beyond the understanding of what most of the readers could comprehend. In these circumstances, the arbitrary withdrawal of nature from inquiry, which has accepted as legitimate until addressed in the one body obliged to answer, it is removed from the potential victims of scientific research, their only remaining safeguard. The Royal Society, the supreme scientific body in this country, can freely violate its foundation principles, as in fact it is doing, and the public, whose servant it is, cannot question it, however clearly the abuse may be perceived and established. Such are the spirit and the conditions in which scientists in this country at least assume responsibility, which the new scientific age lays upon them. So there's great implications here that when a paradox so simple that, as the dude said, a 10-year-old could understand it, or it requires no super intelligence to understand it, if it becomes unquestionable, then everyone's just going to have to take everyone's word for it, and there's no outlet for dissension or questioning or anything. And then in the third part, he says, the state of affairs seems to me so intolerable that no effort should be spared to rectify it. Every attempt to do so, which I have made over the years, and such attempts are made too far and various to be recounted here, has met with frustration. Those directly involved will do nothing, and the others, whom the facts to be related find them incredible and then dismiss them as unreal. I can now see only one way to open non-fellows of the Royal Society. The president of the Royal Society is fully aware of all these circumstances and is satisfied that they are right in ordering. So basically, you know, when the Royal Society investigated John Maddox's behavior, they were like, it's fine. He did the right thing. I believe that this satisfaction would not be shared by the public if they knew the actual state of things, and the only means remaining to me of informing them is to make open charges against the president of the Royal Society, as will compel him to sue me for libel, whereupon, withholding nothing, I shall be able to expose the situation that would profoundly shock those holding the popular belief in the dissenteredness of the scientific research. I do not overlook the probable consequences, both immediate and by repercussion, of the action for various reasons, both personal and general. I would do anything possible honorably to avoid it, but since the only alternative is that they have left me with is passive acquiescence, of course, or in a course of degradation, which, if unchecked, must eventually lead to moral and physical disaster, I have no real choice. So he's saying, bro, I got to catch a case and get criminal charges brought on me so we can go to discovery so I can make all this public for everybody. Like, it's the only way to get this out. Like, so he wrote that to his boys. He published 300 or he didn't publish them. He sent out 300 letters to the fellow Royal Society members. And of those Royal Society members, he got 12 replies back. 10 of them were apologists. One guy said, hey, I agree. That's messed up. And the other guy said, hey, man, that's real messed up. I got my boy McCrea over here who says that he has an answer for you. He's going to talk to Maddox and get this all published and let you guys hash it out, because that's not right. So shout out to, what was that guy's name? King Healy. Shout out to that guy. He made it happen. And then shout out to McCrea, who stepped into the ring to at least try and add a refutation. So before they get into the refutation, one of the editors makes a comment, or like makes a preface in the publication. This is titled, "Don't Bring Back the Aether." And he goes on to just gaslight, poison the well, and ad hom our boy, saying things like calling the questioning of the paradox, an elementary fallacy. Just doesn't explain how or why it would work. It gives no explanation or no backing or anything, right? But just has a bunch of gaslighting in prefacing that Dingle is basically retarded, and don't worry, my boy McCrea is going to step in and knock him out. So we'll get to what McCrea says here. So what ultimately happens from McCrea is he's saying that about the first thing of relativity does not deny the operational meaning of the notion of simultaneity at two different places. Naturally, this fundamental feature in the theory is not affected in the slightest by an arbitrary convention. We may adopt the synchronization for clocks. And then he goes on to say in his explanation for why the time dilation is not reciprocal, which disagrees with Einstein. Now, keep in mind, both of these lads, Dingle and McCrea, they had never read Einstein's 1922 publication where he did the mutatis mutandis, where he's saying that it has to be reciprocal in both frames. That was published in German, and it wasn't translated for a while. So, and back then it was hard to come by information and stuff. Basically, unless you knew what you were looking for, you would just have to stumble upon it or something. So these guys didn't know like that the reciprocal time dilation had been canonized and is mandatory, even though it's pretty obvious from the framework. You can deduce it. But anyway, he argues against it, saying that concern two distinct sets of events, and so they cannot contradict each other. So he's saying that these two clocks, when they're synchronized, these are two separate events, and the relative motion between them doesn't need to be reciprocated. And like I said, that goes directly against Einstein. So quick refresher here on what Big Ein said. These two consequences, which hold mutatis mutandis for every system of reference, is has to be vice versa. So they didn't know about that, but Dingle was obviously on the correct end of the argument, while McCrea was arguing against relativity and Einstein, while simultaneously saying that he was, supporting it, but just didn't realize, how. Because when you're trying to resolve these paradoxes, they can only be resolved by violating the principles of relativity and ignoring the outcome and the consequences of the constancy of C, and not being able to distinguish between reference frames and stuff. Let's see. So Dilections. So Einstein, so to add some more muddying to the water, what year was this? 1918. Einstein published in a German publication that was translated in 1995, I think, or maybe 2002. But anyway, so this was he basically like did a self, he never debated anyone, but he debated himself in a paper that he wrote where he convinced himself that he resolved this paradox by invoking acceleration and external forces, which he flips on and off at will to say that, you know, this is why the motion doesn't have to be reciprocal, because of deceleration and acceleration periods and traveling through a gravitational field and all these things make it so that that what he said about special relativity and how it has to be reciprocal doesn't apply. And he goes on to say that the calculations show that running ahead amounts twicely precise as much as the one lagging behind during the procedural steps 2 and 4. This analysis clarifies the complete paradox to which he referred to. Now, he didn't show any calculations for this or where he is applying these accelerations or external forces or gravitational fields to come up with this solution. He just, you know, states it here and gaslights himself in a self-debate, and then later concludes that you drive a hard bargain, Einstein, but I don't agree with what you're saying, but it makes sense. Like, all right, dude. So what really happened here is Einstein casted tempus dilatum, and that's a card in magic where it mystifies the target into believing non-existent mathematical equations provide a resolution to a paradox or logical contradiction in reality.
Cough, the other day you made a Franco cough. Cough, cough, Franco, so cough, cough, cough.
Thank you. So here we have, but the special theory is taught distinct. Let's see. Don't remember what this is from, but we'll read the highlighted portions anyway. But as the special theory of relativity is taught, a distinguished state of motion does not exist, and where in that why there is no ether of old in the sense. Oh yeah. So this is fuck, I forget who it is, but they're talking about why they had to, you know, with no ether or whatever, and no absolute simultaneity or whatever, that all this is on the up and up. But while the special theory of relativity, portions of space without matter are devoid of an electric field is truly empty, it is quite different from general relativity. So Einstein was saying here that this is just something that I thought was interesting, because, you know, they removed the concept of the ether for the special theory, but in the general theory, he was like, listen, you can think of the bending and warping of space-time as a fluid medium, but you know, don't go attributing physical properties to it, and don't try and use it as an absolute reference frame for motion or simultaneous events. So that's shout out to Einstein. So anyway, Muller in 1952 picks up the torch for the twin paradox situation, trying to give an answer to it. And he says, finally, so he does the same thing. Like, it says, this is basically what Einstein did in his self-debate, was just basically a confidence scam, where it's just like, trust me, I'm Einstein. I got all the math. I just debated myself and convinced myself that what I'm saying is true, so it must be true. And then Muller's like, hey, I can do that too, bro. I got your back. So he says, finally, it decelerates and stops at the origin where it begins the journey. Muller shows that the phase difference of the acceleration and deceleration do not count because they are taken as instantaneous. Einstein, on the other hand, relies on those phases as contributing to what he says are exactly twice the slowing down as the occasioned in the steady speed state when it's at a constant velocity, to get the result that he required. Muller rejects the reasoning used by Einstein. Muller actually referred to Einstein's 1918 paper in his book, but does not mention it in his discussion on the twin paradox or anywhere in the text. This is very strange, because he annotates every other reference in the book to the page where it is used. So, you know, he just did the same thing basically and started arbitrarily applying math to make it work out, and then couldn't justify how or why he applied it to the situations he did. And how he applied it actually contradicts what Einstein had canonized in his 1918 paper, and your boy didn't even reference it in there. So in addition to that, it gets even worse because through the history of all this, there have been 54 attempts to explain the twin paradox, all giving contradictory answers to one another, and more importantly, in contradiction to what Einstein says. So we'll read a couple of these, and then I think that's about the end of the prez. So let's see here. Paul Langevin in 1911. Did I nail it, Stone? Give me a Langevin.
Very close. That's Langevin.
Langevin. Ah, dang it. Okay. Paul Langevin in 1911. He seems to be the first proponent of the paradox. He thought that the difference was caused solely by acceleration, occasioned by the reversal of traveling twin in the direction going back to Earth. So like I was saying earlier, when they get into this situation where they're like, well, when they come back to return, they have to decelerate, accelerate, and this causes a break in the chain where their time dilation wouldn't have to be reciprocal. The most certain experimental facts of physics enable us to, this is from Langevin, messed it up again. Now it's back in my head. Anyway, the most certain experimental facts of physics enable us to confirm that will be so. Langevin asserts this by the meaning of relativity theory just has to be correct when he agrees that each of them will see each other age by 200 times or more slowly than usual. He asserts that it is only in the traveling twin who is aged more slowly. Langevin also states that each of them will see the other live to a life which is greatly accelerated 200 times more quickly than usual when the return journey of the traveler is considered. However, from these contradictory facts, Langevin still comes to the strange conclusion that only one twin will be slower. Significantly, he shows no calculations. So we got some missing math.
I'm shocked.
And just assertions. We got Brewster here in 1956. It depends on whether you say the spaceship is moving away from the Earth or or the Earth is moving away from the spaceship. No matter which brother you are, you will see the other aging faster. When the two of you are back at home, however, one will be not older than the other. So this contradicts the entire theory. This is just like, oh, it's just.
But he solved it, right?
Yeah, but he solved it exactly. Exactly. So Louis Essen, who was a beast, and also got the same Einstein treatment when he started questioning relativity theory. When he retired, he became, a crackpot and all these things. But this is the man that invented the atomic clock. So he knew quite a bit about what he was talking about. And I believe he taught relativity for a number of years as well before he retired. So he was definitely qualified to speak on the matter. So he says, students that are told the theory must accept, although they cannot expect to understand it. They are encouraged right in the beginning of their careers to forsake science for dogma. So agreed. This is the only way that it can be taught. I think, Shane, was it you who quoted the only way that relativity can be taught to the student is through deception? Do you remember who said that?
Yeah. I think I threw that in the debate.
Yeah. So, you're trained right off the rip to just go for dogma. You have to adhere to relativity at all costs and never deviate. So Prince and Gerber here give an amazing conclusion to their paper, which says, we have given different answers to the question, where does the differential age occur? 1, it occurs during the twins' rocket ship. 2, some occur in the twins' early pre-rocket years. The pre-rocket years. The lack of a unique answer shows the lack of meaning to the question. Oh, dude.
They got prolific on you, dude.
The age difference in relativity has a well-defined meaning. Oh, but the origin of the
what he
age
said
difference...
was, what depends on the definition of is essentially. That's what he said.
Especially.
Let's break that down a little.
Yes. What is the definition of is?
Oh, jeez.
So this explanation is one of the most outlandish of all. It proposes that some of the age difference that is subsequently caused by the high-speed velocity actually happens before the travel starts, bro. The ultimate
Dude, how
gaslight.
profound is that, right?
Dude.
How profound would that be if it happened before you even counted it? Now what?
All right.
Who else said that they about relativity mistaking profundity for like whatever? No, mistaking just like the absolute obnoxiousness for profundity is kind of the hallmark of relativity. Like, ooh, no, it's retarded. It's retarded. Stop it. You know.
Yep. Now we're going to cover a couple of experiments that are said to prove relativity theory's correctness, meaning time dilation experiments and the muon, and asymmetry in the analysis between these. So, 1 second. All right, so we have Heffel and Keating, 1971, where they did their famous around the world atomic clock experiment that is said to confirm relativity theory. What happened was on the plane, the clocks all went out of sync with respect to one another at varying degrees, and some of the clocks, the shifts were so big that they were outside of the error margin, they were outside of the predicted amounts, that they had to actually reset the clock. And this happened 7 different times. Or no, I'm sorry, it happened 12 times. And to one clock specifically, it happened 7 times. And they were like, let's just reset these and keep it on track, boys, and, not talk about that. And in a FOIA paper that A.G. Kelly requested, because their research was done by it was funded by the Navy. So he was able to FOIA the debriefing that they gave. And he found like where the uncorrected values were just insane and didn't match prediction at all. And in the follow-up publication in 1972, they state that relativity theory that they actually matched the predictions after they did their calculations, which is they never showed what they did to correct for it or whatever, but they brought it in line with relativity and then declared that relativity is correct. And here we have a quote from Heffel from the FOIA debriefing that says, "The results of the analysis are in reasonable agreement with the predictions. However, those who doubt the validity of the convention of the theory, and there are many people in that category, will probably not be convinced by the results in Figure 4. Indeed, the difference between theory and measurement in Figure 4 is disturbing, and our final analysis does not improve the agreement and improve the versions of the experiment should be given serious consideration." But then, like I said, a year later, they went ahead and published everything with corrections and gave agreement to relativity theory. And next we have the old muon, who's said to come in from cosmic rays, and when those rays interact with matter in the atmosphere, the virtual particles and whatnot, muons are exploded out of that interaction. And then those muons have a decay. They measure them, on Earth. So they're like, okay, well, at ground level. So they're like, okay, well, in order for a muon that was created up here to get down here, you'll have to experience link contraction and time dilation. So this isn't a homeless person squatting in a bathroom at 7-Eleven. This is a guy in a basement with an oscilloscope about to do some measurements of a muon. And here we have the muon, aka a blip on an oscilloscope, that is supposed to be proof of time dilation and all this stuff. So, real quick here, we'll get on the. Nope, that's not it. So, for the muon, we'll say in the muon's frame, they're only experiencing time dilation in the lab. They only account for time dilation. They don't account for link contraction. So they're violating Lorentz symmetry in that. And then for the muon frame, so if you were to take the frame of the muon, you would say that it's experiencing time dilation and the Earth is moving towards the muon. Now they don't do that in the lab because obviously the lab isn't rushing towards the muon. I mean, that's just self-evident. So they don't even attempt to describe that. And in doing that, only applying 1/2 of the Lorentz transformation, they're violating Lorentz symmetry. So they're not even giving an adequate explanation, within the framework of the theory to apply time dilation as the mechanism that explains this interaction. So that is the history of time dilation and all that. If anyone has any questions, comments, or concerns, you are free to do so.
I like how they invited everyone to solve it, but then told them to do it separately, and then brought them all together, and they were like, "You're all wrong because none of you agree." Brilliant, brilliant way to do it.
Yeah. Yep.
I just want to say, as someone who's done drugs behind the 7-Eleven, behind the dumpster, I've transcended space and time and dilated that kind of stuff. So, I mean, is it that far-fetched? Come on, dude.
Dude, I love how bums doing drugs in science of the 50s look so similar that we actually need a disclaimer to be able to distinguish.
Nice.
You make it black and white. It's hard to tell. Like, what is that guy doing? Is he huffing paint? No, he's doing science. Okay.
Is that a broken light bulb? What's he about to do with that? I don't know. Is he about to do some
school freebasing method out of a big drug?
freebasing out of a light bulb.
Yo, you ever tried Muon? Oh my god, dude. What a
I think the
trip.
only difference I see between this picture and the other 7-Eleven picture is that this guy, I'm thinking, still has all of his teeth.
Yes. Very, very likely does. And he also has an oscilloscope. And drug users in a 7-Eleven almost never have oscilloscopes.
Oh, there was that one though, right? You had to say.
Yeah, but that one was hot.
I don't know what I called it.
He's stolen a oscilloscope.
Never say never.
Yes.
Look, if you ever find yourself in the position, just tell the cops you're looking for your keys. They'll help you look for them. Even though they don't exist, that is still a good way to get out of the whole thing.
I feel like that's a real story.
It very much is.
You know, I sorry.
Go ahead, Liliana.
Oh, I was going to say that, you know, this whole idea of dilating time and space, it's like saying that you're going to, like, you treat my imagination like it's a, you know, lump of dough, and then you can stretch it and pull it and shape it. They treat time and space as if they're actual tangible things, when really time doesn't really exist. All we have is this moment. And, you know, we just use clocks as a way to just measure something that we constructed, which is really imaginary, which is called time, you know. And then also the same thing with space. We just use measuring tapes and stuff to measure it, but it's really, both are intangible. You can't shrink space, you can't expand space, in spite of them, you know, telling us that the universe is expanding. It's just as silly. Anyways, that's my comment.
Thank you.
I agree. Time as a dimension is very silly, but required for things like the results of Michelson-Morley if you want to if you want to pretend that the Earth's in motion, you know? So
yeah, at the very least, it could be said that it's, you know, absolute, right? You can't go backwards in time. All you have is that moment that's moving forward constantly. So you could make a measurement of like a point in time, you know, after or as time moves forward, but you can't go backwards in time. You can't slow down that forward movement of time, right? Only mathematically you can, but in reality that doesn't happen. And to let's see, to clarify, right? It's like, so why did these clocks go out of sync then? Why were they, what was the issue with them? Well, the stationary clock, which these clocks were in reference to, didn't show any reciprocal time dilation, right? Only in the moving frame. And a prediction of the classical theory, and especially with the Sagnac effect, is that you will experience retardation proportional to your velocity with a 1-to-1 ratio, not a ratio that's that's a function of the square of the velocity over c squared. So simply movement through a field would cause this retardation. And then as far as the situation where the clocks went out of sync so much that they had to be reset, something like that was actually noted by Louis Essen, who was the creator of atomic clocks, and he had no explanation for it. But sometimes these clocks would just crazy get out of sync, like for no reason. It would just, you know, a huge blip on their oscilloscope. It's not what they use, but it would just, you know, there would just be a huge swing in the fluctuation there that they had to correct for. So with there's no reason why. There's no like periodicity to it. It doesn't happen on cue. It just sometimes happens. So nobody knows.
I did spot in the verbiage you flashed up about the airborne experiments they did with multiple clocks that they stated that they needed to reduce their drift inaccuracy by 2 orders of magnitude in order to do a competent experiment.
Yep. Yeah, it's like I don't have the error bars, but in that paper though, when he was referencing figure 4 there, yeah, it's way off. It's not even close. And they were like, you know what? Here's what we'll do, boys. We'll publish another paper, say we made corrections, and then these corrections will give close approximations to the theory, and we'll say that we're good to go. Like, oh, nice.
Close approximations are all we need to hang in the theory, guys.
Muons reach closer to the ground on the side of the Earth. Oh. So Hercules asked, do muons reach closer to the ground on the side that's supposed to be, you know, in the direction of motion of the orbital velocity, or when it's away from the orbital velocity? And I don't know. I don't think anything like that's ever been published or anything. I don't have any data on that.
Hey, I've got a question. You said something about how you had all these scientists who were coming up with their own theories about the whole thing, and they were all contradictory to each other. Did no one like seem to spot this or notice this, or
so
like was it just ignored or what?
Yeah, there was a couple of people that noticed the issue and commented on it, but I didn't include those. There was only like 4 or 5 out of the 54. And Lewis Essen was probably the best one. But yeah, they're just like, I don't know, it just works, bro. It's relativity. Shut up. Don't question it. Because it's not about
You
finding
said
a
out of
solution.
54?
Yep.
Jesus.
Yeah, only 5 like actually acknowledge the issue. And most of them, like I said, just would give answers that are just nonsense. Like my dude said that what was that guy that's, oh yeah, these 2 geniuses, the time dilation happened before the event even occurred, bro. Like that's insane.
Dude, I figured it out. They hit it in the beginning before time was counted. That's how you get the time dilation in there. That guy coming forth with it as if it was like, behold, I've solved it. You ready? Before they leave, before they get in the ship, they're already older. Boom.
Yep.
That's ridiculous.
The confidence of someone, though, like with a PhD, they'd be like, listen to me, I have credentials. The twins are already older. Boom. Profundity.
Amazing. If you give someone like a little certificate, what they can do with that. You know, like, I'm a PhD in astrophysics. I contribute to society. Like, get the fuck out of here. Sorry.
Yeah.
Nice presentation, though. I feel much more confident in insulting people who believe in time dilation now.
Yeah, well, yeah, and don't forget, like the key to the argument is these are all one-sided confirmations, right? And relativity theory requires 2. Requires it to be reciprocal, absolutely mandatory. And most people don't even know about that. They don't include that in textbooks. They don't talk about it because it's preposterous, right? So they don't even want you to think about it in that way. They just want you to think of the one experiment being like the confirmation of it, like the one way. I'm sorry, the one way measurement of it is confirmation of it when it has to be reciprocal.
Yeah, don't look over here, look over there. And actually, my results are better than your results, even though we both did the same experiment. That's it.
Yeah, and the reason my experiment worked out is because I did it before I even did it. So that's how I got the results.
I'm gonna keep using that.
That's the ultimate gaslight. He's like, bro, your questions were retarded. They already aged
before
they even
you
did
asked it. Yeah, I never thought to answer a question like that. Like, bro, you missed it. I answered it before you asked it. You have to go back. Oh, you don't believe in time dilation? What are you, a flat earther? Jesus.
Yeah,
But it's pretty retarded how grown men can treat something that's imaginary as if it's something real in our tangible world. That's what I find really retarded.
The amount of energy grown men will put into defending this fantasy, yes, is staggering. Absolutely. And emotions get involved, which is also staggering. You don't like my retarded fantasy? Well, I don't like your retarded fantasy. Well, fuck you. Like, wait, what?
But as long as your retarded explanations agree with the retarded fantasy overall and support it, each individual retarded explanation is certified.
Okay, but the collective amalgamation of retardation put forth doesn't actually agree with the primary retardation. So then, therefore, it's all retarded, I think.
Yeah, so that's when you get into retardation squared.
Oh, yes. I have to plot that out.
You know, I feel like this is just a really gross misuse of math. Like they took math to do all this mathematics. It makes me wish that they'd never discovered the numbers. I wish they had just stayed with the Roman numerals, because maybe we wouldn't have had all this horrible mathematics imposed upon us, you know?
Well,
Nah,
math is a weapon, right? They use it to prey upon people who don't wield it themselves. But who was it that said, like, the scientists of today invented their own language, so to speak, which is the higher level mathematical jargon that we're talking about? Because if they had to say in front of the real people, like, what they were actually looking into and what their positions were, people would laugh at them. So they don't say it in layman's terms. They say it in the scientific jargon so that you refer to them as, super intelligent, and you get this mysticism air about it because you don't really know what they're doing. And the point is, nobody does, right? It's all retarded.
Yeah, that was Michael Brenner who said that.
Hell yeah. I got to remember that when I quote people who actually said the quote.
Yeah.
Wait, what did he say?
He said
Michael Brenner say?
that mainstream physics and science has been hijacked by by the language of mathematics, and anyone that doesn't speak it will look at it with profundity because, it looks nice and fancy and clean and elegant, even beautiful. But if the physicists had to tell people what the equations mean and how they're using them and what they believe they represent, it would be revealed that they're retarded.
I think that was much more elegant than even Brenner said. Actually, can we clip that out? That's going to be it. That's perfect.
Yeah.
One of my favorite Brenner quotes was, reality doesn't care which reference frame you choose.
Yeah.
Right.
Yeah, but Liliana just quoted Brenner without even knowing it. That's what got us all started. She just said, I think it's retarded that they use this mathematical speak to confuse us. And I was like, oh, that reminds me. That's exactly what they do by choice and profession.
Yeah, and like Dingle pointed out, they have an unprecedented amount of control over information and the public because the public just has to trust them, right? Like people that don't have time to look into this and stuff and understand it and build upon it, they're not going to, they just have to take the word of the scientist for it. And if you can't question the scientist and physicist about this, then you just have that's just a breeding ground for corruption. Like it may have seemed like he was being a little over dramatic in his letter, but it's like we're looking at the consequences of it right now. Physics is at a grinding halt, right? They spend billions of dollars building hadron colliders to do nothing.
Dare you say that? We find planets all the time.
Yeah, and it's just like they've reached the end of this, and there's no outcome. Like there's no resolution to it. Yep.
Yeah.
Yeah.
Nothing left. Yeah.
You know what else?
Philosophers have been saying forever, that there's no such thing as time, that time is just an illusion, because all we have is this moment that is constantly slipping away, but all we have is this moment. And so I think this was a way for the scientists to use their mathematics to basically make us completely ignore or discount, treat those philosophers as if they didn't know what they were talking about.
Yeah, when you can't attack the idea, attack the messenger, right? Get him.
Shoot him.
Don't listen to that guy. He's retarded. Everything he says is wrong. But One more thing on time dilation. I think it's necessary, but also it's perpetuated so heavily in the culture. Like just today, I saw 4 movies about time travel, time dilation, like an episode, everything. And you look in a comic book, every like subplot, everything that goes back in time, every movie, it's all crazy. So that by the point of you're trying to ask yourself, is it real? You've already suspended your disbelief for so long. It's hard. But that's why they all accept it. Like, of course we can travel in time, and it makes sense, right? Because of everything that every movie is ever. Boy, you never Back to the Future, dude.
Yeah, dude. In one of the Spider-Man movies I was watching, like one of the recent ones, there was like they bring in the 2 other Spider-Mans from other universes or whatever, you know, but they're all connected to the same universe or whatever. But anyway,
Multiverse one, yeah.
Yeah, when they meet up, he's like, he has some technology or references something about some technology or thing that's not existent in our reality. And he's like, oh, no way, that's real? We haven't confirmed it here in our world yet. They're like, you know, putting these ideas forward that this is all possible. And like in another reference frame, all this was confirmed and validated. And, you know, you'll get to it soon, but because our timeline's ahead of yours, like you're just not up to date yet. It's so...
Right.
Yeah, like that's how they do it, man. They just propagandize it to infinity, mythologize it, put it in the pop culture. I mean, nobody knows what a black hole is, but everyone's seen, you know, Interstellar.
But everyone knows of them. Yeah,
right. Everyone remembers that cool scene where he goes through the black hole, but he gets you know, time dilated or whatever, so he stays the same age and his daughter ages like 80 years. And oh dude, it's so sad when they meet because he's still young and she's actually the old one. And it's like, that's retarded. Now we all see
true.
that. Now we all see how dumb that is.
Dude, they did the twin paradox, but in reverse, except she never traveled.
Right.
I didn't realize. He goes into the black hole and then talks to his young daughter. Yeah, that makes a lot of sense. And everyone was like, oh, the plot is so profound. Look how grounded in real science it is, right?
Yeah.
I used to like Interstellar too. It was one of my favorite movies. So I learned a lot.
You're still allowed to like it.
Dude, how about like Neil deGrasse Tyson making like critiques on it or whatever about the scientific validity of it? And it's like, bro, the whole thing was based on a paradox that is unresolvable and makes your theory retarded. You didn't address that though. That was the good part of it. That's what they did right. They did black holes right or whatever. It's like, okay, dude, is that what they did? They nailed that one.
Yeah. Yeah, I mean, it's one thing, you know, to have all this time dilation and whatnot and time travel in fiction and in movies and in stories or whatever. But when they try to actually tell us in college and university that this is somehow relevant and part of our physical, tangible lives, that's where the deception is. You know, they really have to make that separation and say, hey, this is just in the world of imagination. It has no relevance to our actual, real, tangible life.
None whatsoever.
I think the cool part is realizing how the chain of sophistry happens. Like Alan was talking about the asymmetry with the round trip of one of the twins to break the asymmetry. That is what causes the shift in simultaneity to explain why the passing of time is slower for one twin. His or her clock ticks slower, resolving the paradox. But as Alan showed earlier with the balance beam example, we know simultaneity is not relative. It's an oxymoronic term in and of itself.
Yep. You're either simultaneous or you're not.
How about the guy with the stones who was ready to get sued? So we can have this on record. Like, let's bring it to court.
Dude was trying to catch a case. He was like, I don't want to do it, but I might have to like threaten this guy's life.
That was the I dare you of the decade.
Yeah.
You guys discounting partial simultaneity? That's not a real thing. It's either total simultaneity or nothing. Are you sure?
Yep.
And to have a little bit of simultaneity if I want it, like if I want to try and dip my toe in, if I don't like it, I can give it back.
Yes. All right, lads. Well, that wraps up the Prezi. So unless there's any other questions or comments.
No, sirree. Great presentation, bro.
Thank you, sir.
I think I
What?
should probably clarify for the girls in the room. It wasn't a dumpster behind 7-Eleven. It was bushes in front of the Cafe Rio. So it's not as bad as it sounds.
I like how you clarified it. That's much better.
Yeah.
Well, reference frame matters, I found out.
We're learning.
Yes.
Yeah, that's true.
Yes. Did you
Oh
have
yeah,
a?
yeah,
Never
that
mind.
helps. Where's Toby these days?
He's taking a vacation.
Thanks to Brush
Not
Tail
allowed.
Coffee.
He's
thunderous success.
he's doing extensive research in Antarctica, trying to find the best flavor of penguin. I mean, the best penguin to not use as an ingredient to the
non-baby
coffee.
beak.
Yeah. Yes. So hopefully he returns from the expedition safely, and we look forward to his return. And speaking of brushtail coffee in Antarctica, Lily, there's a couple of lads in December that are going to Antarctica, and they're not going to have any coffee to take with them. What do you think they should do about that to stay warm?
Oh, why can't they take coffee with them?
No, I mean you should suggest that they should take it.
Oh, yeah, but they should.
Let
They
me
should take coffee with
Yeah, go ahead.
what?
I was gonna say. Let me rephrase my pre-dunk for you. If you were gonna go to Antarctica and you were gonna be super cold, and you could take one drink to keep you warm, what would that drink be?
Oh, it would definitely be brushtail coffee. And also, I mean, it has so many miraculous powers. Did I ever tell you about this other testimonial that I had?
No. What is it?
Yeah, so I used to have this very, very rare medical condition, another very, very rare medical condition, and it's called Podus lucrum summa syndrome.
Ooh.
It's also known as by a shorter name, and it's called Garima syndrome. And what that means is that it's an emotionally induced weight gain. So it's not weight gain as in getting fat, but it's more like, what would normally be 1 ounce of your body suddenly becomes 10 kilos. And
Oh, wow.
anyways, long story short, when I was a little kid, if I ever got really upset, I would stamp my foot down, and then this Podus lucrum summa syndrome would kick in, and then I would create like this pothole. And so my poor parents, we had to keep moving all the time. And as I told you guys, we were poor, and then everywhere we went, every town we lived in, there was always potholes happening, and potholes. And it was in the newspaper, and they said, why do we have all these potholes in all these different towns? Anyways, long story short, when we moved to the States, because I had to really control my temper a lot, which is difficult, And so long story short, when we moved to the States, I started drinking brushtail coffee, and now my Podus lucrum summa syndrome is gone. I have been cured by brushtail coffee. Yeah, so there you go. There's my testimonial.
Beautiful.
Thank you for that testimonial. And again, Brushtail Coffee does not claim specifically to cure anything, but we do have anecdotal testimony from Lily, who we definitely do not pay to give these testimonies.
We're probably gonna get sued at some point for proclaiming that it cures
so
blindness.
as far as I can tell, this is just an honest woman who had a troubling ailment, a birth defect, if you will, and was corrected through the intravenous use of brushtail coffee. You said you were injecting it, Lily?
Actually, no. No. I wasn't injecting it. I was just drinking it. I just discovered it. But look, I mean, if someone else has Podus lucrum summa and they don't get cured, then that would be a problem. But, it's such a rare medical condition that, yeah, it must be the penguin beaks or something.
There is a magical property to them, similar to unicorn blood in Harry Potter mythology.
All right. It's
All
pretty
right.
good.
All right, lads. So what we got coming up for the rest of the week, tune in on Thursday at 7 p.m. Eastern. We're going to be starting a little early. Research and Reading Night is canceled, but we're going to be replacing it with Robert Bennett and Professor Robert Parks. They're going to have a conversation about geocentrism and heliocentrism. So if you guys have questions for them or anything like that, you can email them to me or Bennett in the meantime and just title it Thursday or something like that so I know what it's in reference to. And then we'll make sure we get those answered.
Wait, so that's this Thursday, on the 17th?
Yes,
Or
sir.
like when my debate is. Crap, I forgot.
Wait, what time is your debate?
Now, what time is it? We should make it earlier or later? What time is the Professor
There-
Parks?
Their conversation's at 7 p.m.
And that's going to go for super long. So
Yeah.
earlier? I don't know. We got to sort that out.
Wait, what time's your debate, Shangy?
I thought like 7 or 8. So that's
Yeah,
a
yeah.
conflict.
Yeah, and you can't do it earlier because you'll be at work, huh?
Yep.
No.
We'll sort it out.
Yeah, we'll try and get that sorted out. But also Shane will be debating on that same day on Jaren's channel. So check that out as well. And we'll see if we can get the time dilation sorted so we can watch both events simultaneously.
When you really need time dilation to be real, huh?
Right?
Who are you debating, Shangy?
Eyeball, a random dude on Twitter about optics and Earth curvature again.
Oh, wow. Sounds exciting.
Should be fun.
Yep, it'll be awesome. And then the following Friday will be Flat Earth Fridays, episode 115, boys, the big 115. And then on Tuesday, Shane, do you have anything queued up for Tuesday or nah?
Yeah, so because of the debate, I'll have a nice probably 60 to 80 slides on bottom-up obstruction with specific focus on angles and unequal angles.
Nice. And we'll probably do a debate review too on that as well after you do the prez or something. We'll kind of touch on like the points you made and what you argued and stuff.
Nice. Yeah, they'll definitely be related.
Cool. Yeah. So Tuesday we'll be doing that. And then the cycle thus repeats itself. All right, lads and ladettes. See you guys on Thursday.